Okay, problem 45 says based on the model, normal 1152, comma 84, says describing Angus steer weights, what are the cutoff values for the highest 10% of the weights, the lowest 20% of the weights, and the middle 40% of weights? So we will just take these one at a time. And A asks for what is the cutoff value for the highest 10% of weights? So here's our normal distribution. We're centered at 1152, and we want to know the cutoff value for the highest 10%. So we know that 10% is in this tail, so that's proportion is 0.1000, and that's the and we want to know what is this cutoff value. Okay, so if 10% is if 10% is to the right of the cutoff value, that means 90% is to the left of the cutoff value, and that's because the entire thing adds up to 100%, or 1.0. So if 0.1 is to the right, 0.90 is to the left. Okay, and so we want to look up the area 0.900 and find the corresponding z value. So the area to the left is equal to 0.900, and the corresponding z value, okay, so we look up in the area of the part of the table, we're looking at 0.900, and the corresponding z value, the closest value I can find is 0.8997. So you can't find 0.9000 exactly, but the closest one is 0.8997, and that corresponds to a z value of 1.28. Okay, so again, it's very important that you don't look up the z value of 0.90. You're looking up the area is 0.9000, or the closest one possible, and that is 0.8997, and that corresponds to a z value of 1.28. And so once we have the z value is equal to 1.28, then we can plug it into our formula, and so this is our z. Z is equal to 1.28, and that's equal to y minus mu divided by sigma. Okay, and we know our mu is equal to 1152, and we know our sigma is equal to 84. Alright, and so now it's just a bit of algebra. So we do 1.28, we multiply both sides by 84. Okay, and so on this side, and then we add 1152 to both sides. So on here we have 1.28 times 84 plus 1152. Whoops. 1152 is equal to y. And when we do this calculation, 1.28 times 84 plus 1152, we get y is equal to 1,259.52. So I'm just going to round this off to 1,260 pounds. Alright, so this is the cutoff weight, 1,260. That's the cutoff weight where we separates the highest 10% from the other 90%. Okay. Part B then asks for what is the cutoff value for the lowest 20% of weights, the lowest 20% of weights. So here, again, we are centered at 1,152, and we're looking for the lowest 20%. So here we've got 20% in the tail. And this is already to the area to the left, so we don't have to subtract anything from 1 or anything like that. We just know that the area to the left is equal to 20%, or 0.2000. And so here we're going to the area of the table, and we want to find the corresponding z value that has the area that's closest to 20%. So I go to the table and I'm looking up for the value that's closest to 0.2000. So here the closest I could find is 0.2005, okay? And that corresponds to a value of negative 0.84. Negative 0.84. So here I've got a z value equal to negative 0.84, and again, This is just algebra. Negative 0.84 is equal to y minus mu divided by sigma. Our mu is 1152. Our sigma is 84. Alright, so just take my word for it. If we multiply both sides by 84, negative 0.84 times 84, and we add 1152 to both sides, the value that we get, 0.84 negative times plus 1152, we get 1081.44. Okay, so I'm just going to round this down to 1,081 pounds. And this is the cutoff for the lowest 20%. Alright, so that's part B. And finally, part C asks for, I believe, I lost my place in the book, so give me a second to look it up. Part C asks for the middle 40% of the weights. The middle 40% of the weights. So I'm going to go ahead and just erase what I've got here. Okay, the middle 40%, again we're centered at 1152, that's the mean. And the middle 40% means we've got 40% in the middle. Okay, and so the total area on the outside is going to add up to 60% because everything adds up to 100%. So if we got 40% in the middle, everything on the outside adds up to 60%, because 40 plus 60 adds up to 100%. And because it's perfectly symmetric, half of it is going to be 30%, and the other half is going to be 30%. So we want to know the values here and here to find out the interval for the middle 40%. Okay? Now, one of the neat things about the normal distribution is that it is perfectly symmetric. Okay? So whatever the z-score is on this side, we will have just the opposite z-score on this side. It'll just be the negative value on this side. Or if we find this one here, we find the negative first, we'll have just a positive value over here. Okay? And that will reduce some of our lookup time. But I can show you this exactly in both ways. So first, we're going to find the z-score corresponding to an area where the left, so again, the area to the left is equal to 0.3000, and we're going to find the corresponding z-score. So we go to our z table, and we look up, we're trying to find the area that's closest to 0.3000, and the closest value I can find is 0.3015. So the closest is 0.3015, and that corresponds to a z-score of negative 0.52. Negative 0.52. Alright? So from symmetry, I know that this z-score is going to be positive 0.52. But I can also show it to you guys. And so the area to the left of this point, if 30% is above, then that means 70% is below. So the area to the left is 0.7000. And if I look up 0.7000 in the area of the table, I'm not in the index, but the area of the table, the closest value I can find is 0.6985. So the closest is 0.6985. And that corresponds to a z-value of positive 0.52, 0.52. Alright? So I could have just shortcutted there and known that was going to be the answer. But we can also look it up in the table. And again, once we have our z-scores, now it's just to convert using algebra to find y minus mu divided by sigma. So our mu is 1152 divided by sigma, and that's 84. And we multiply both sides by 84, and we have negative 0.52 times 84. And we add 1152 to both sides. And this gives us our y value on this side. And so here I have negative 0.52 times 84 plus 1152. Oops, I think I messed something up there, so let me try that again. Alright, so I get y is equal to 1108.32 on that side. And on this side, 0.52 is equal to y minus 1152 times 84. And again, 0.52 times 84 plus 1152. Solve for the y. And I know I'm doing the algebra steps relatively quickly. But I'm hoping your algebra skills are up to speed there. So we do 0.52 times 84 plus 1152, and I get 1,195.68. So I'm just going to round down to 1108 pounds to 1196 pounds. Okay, is the middle 40%. And that is problem 45.